For next question, that is question number 25, we have to observe the following diagram and answer the questions following it. So these are the light rays coming from somewhere from infinity, and the image is formed in front of the retina. So that means that the far point of the normal human eye, which is infinity, it has, so this was a far point of the my, and it has come nearer. So we can say that the far point of the eye, so the far point of the eye that has far point is now nearer than the infinity. So in this case, the far point is nearer than the infinity. The reason here is why we are able to get the image here, because in front of the retina, because the far point which are supposed to be here, which was at infinity, it's now nearer than the infinity. It has come here. So we can write here that how we can identify this, because the far point is nearer than the infinity. So here the far point is nearer than infinity. So that means the far away objects, we are not able to see that. The far point is nearer than infinity. So we are not able to see far away objects. And if we are not able to see far away objects, so not able to see far away objects means that the defect of vision is myopia, which is nearsightedness. So means we can see the nearby objects clearly but cannot see the distant objects distinctly. So the defect of vision shown here is, this is, we can write the defect of vision so shown here is myopia, which is also called nearsightedness, which means we can see nearby objects but cannot see far of the objects distinctly. It's nearsightedness. It's not that we are totally not able to see the far away objects, but we cannot see them distinctly. We cannot distinguish between two objects clearly. So this is myopia, or we can say the nearsightedness. Okay. Now, the next question, we have to list two causes for this. So two causes for this can be maybe this eye lens, this eyeball is too long. So that could be the reason, the elongation of eyeball. So that's why the image is forming in front of the retina. So the reason here is the can be the elongation of eyeball, or maybe the curvature of eye lens is excessive. This eye lens, this is the eye lens, its curvature is excessive, like this. So the second possible reason could be, in this case, this is first, this elongation of eyeball, and second could be the excessive curvature of eye lens. This could be the reason for the myopia, which brings the far point nearer than infinity, and thus the image is formed in front of the retina. So this is the excessive curvature of, we can say, the eye lens. This could be the reason. Okay, now name the type of lens used for the correction of this defect. So this defect can be corrected by using a concave lens. So we have to use a concave lens, which is also called the diverging lens. So if we use the concave lens here, this will diverge these rays of light from okay, let me draw it like this. This concave lens is going to diverge the rays of light to, like this, divert the rays of light and bring them at the retina. So this is a concave lens. So type of lens used for the correction of this defect is a concave lens. Concave lens, or we also call it diverging lens. And let me show you how this is corrected. Let's say this is an eyeball. Again, let's say this is the islands. And now we have to, so the far point is now nearer than the infinity. So it was supposed to be the far point here, but it's now here. So that means from here we have to get the rays of light. So rays of light coming from here. Here it's the concave lens. It's going to divert the rays of the light. Okay, so the rays of the light coming from this. This is the far point, which is nearer than the infinity. So far point is here now. So all the rays of light coming from here, which were meeting in front of the retina, it will divert these rays of light, will bring them out. Okay, let me draw this here. Okay, let this be the ray of light. Okay, now it will divert the rays of light like this and will focus them the retina. So the image is formed exactly on the retina. So the far point is nearer than the infinity here, and from here the rays of light will be diverged and will be brought back to the focus at the retina. So this is how the diverging lens or the concave lens corrects the myopia, and we are able to see the distant objects distinctly. Okay, next question is the color of the sky, clear sky from the earth appears blue, but from the space it appears black. Why? So give the reason for the blue, and for the persons at the higher altitudes it's black. Let's give the reason for that. And the reason for that, the sky to be blue when we see it from the Earth's surface, is that the size of particles in the atmosphere is smaller. So very, we can say the very fine particles or very minute particles present in the sky, they scatter light of shorter wavelengths. They scatter light of shorter wavelength, that is blue, because their size matches with the order of the wavelength of the blue light, that is the blue color or blue light, more than light of longer wavelength, that is red. So that's why the sky appears blue. We can say that is red color. So sky appears blue. And this is because of the scattering of the light by the very fine particles present in the atmosphere. So sky appears blue. But when we see this from high altitudes, and the question is why the Earth appears space it appears black. So when seen from space, because we are at high altitudes, we are out of the atmosphere of the Earth. So when seen from space, there is no atmosphere, and hence there is no scattering of light. There is no atmosphere in between, and hence there is no scattering of light. So if there is no scattering of light, means no colors are scattered, and hence it appears black. There is no scattering of light, and hence from space it appears black. So in this question, you have to answer why it's blue when seen from the surface of the Earth or when seen within the atmosphere of the Earth, and why it's black when seen from the space because of the altitude and the absence of the atmosphere. So this is question number 25. Let's move on to the question number Next question.